Hello, this is Robert Casey, and this is a presentation about creating a YDNA haplogroup project. So if you are interested in creating such a project, this is intended to give you some helps and tips. So why do you want to create a haplogroup project? Well, first of all, you may already be tracking most of the haplogroup already, and also you may want to network with people that have common interests and share your own origins. Also, larger and older haplogroups just can't cover dozens of major haplogroups very well because they're just getting so large and there're just not enough haplogroup admins to really tend these smaller haplogroups. There's a great need for smaller haplogroups that are just not being addressed today because of the explosion of SNP trees and some fairly significant haplogroups that are now getting to be 50 to 100 testers. This is the same state that we were in 5 years ago when we just had very few haplogroups to monitor, but now there's just a large number of them. So just creating a haplogroup project will get the ball rolling. It doesn't require a lot of skill or a lot of time, and so just having a presence of it would be gratefully helpful. But picking the right haplogroup is really key. You don't want one that's extremely old, and you don't want that's very young. So there are some ideal characteristics to pick a good haplogroup. The first characteristic is the age. It really should be between 1500 and 2500 years ago. And the reason this time frame is good is because YSDR signatures work real well in this time frame. You can do Y-SNP prediction in this time frame, and you can do charting in this time frame as well. It should be genetically isolated from others so you don't have overlap of false hits that are going to be analyzed and throw off your analysis. So having 10 to 20 branch equivalents in the upper portion of your haplotree is a good idea. Also, the project should be the right size. If it's too small or too large, it may be too big of a project you take on, or if it's too small, it may not warrant a project at this point in time. The ideal size is like 50 to 100 testers and 10 to 20 branches. That's really the ideal size to get started on. So here is a typical family tree haplotree. We're going to look at A5381. Now, if you look at the chart, it looks like it's a standalone. That's kind of a yellow flag that maybe it's too young to be participating. And then you have two other choices, BY248 or BY246. And it's probably going to be BY246 because it covers all of them, and there's only one branch and one sun underneath BY246. But BY246 may be just too old, and you may have to pick BY248 instead. So do you pick A5381 or you pick BY248 or BY246? What you need to do is you need to go to the BigTree or Y full if you're not R1b and see what the estimated time for the origin of your haplogroup is. And just one branch is almost always too small to warrant a project. You need a lot of branch equivalents and have enough Y-SNP testers to make to have the right dates as well. So here is the BigTree screen that covers this portion. And it jumps right out at you that BY246 is going to be the obvious candidate because of the number of branch equivalents. And BY248 just has one branch and a complex area branch equivalent. So, but there are other characteristics other than branch equivalents to be looked at as well. So BY246 has a great number of branch equivalents, but this haplogroup may be too old still. Also, BY248 covers 5 and 6 branches. So again, BY246 would be the best choice between the two. Also, it covers a total of 7 branches, which is about, in the 10 to 20 range, a little low side, but it's a reasonable sized project. But BY246 has no date, but we can always go to BY248 to see relatively how old it is and see if it's encouraging. So looking at if you click on the BY246, it pulls up the menu and you scroll down to the bottom and it'll give you the estimated time. So for BY248, it's right around 2,400 years old, which is kind of pushing the higher end of the range, but is really kind of the ideal range to have it this old. So it looks like BY246 satisfies the condition for time frames. So it looks like BY246 is the best candidate in that part of the branch. It also has all their characteristics. Picking any lower Y-SNP branch would be just too much overlap with other branches underneath BY246. You really just can't cherry pick your own portion of the tree because you don't know which people under BY246 really belong to your group or belong to another group. So, and picking BY248 is really about the same thing as picking BY246 because the branch equivalents don't really add much to the age, and there's only one real SNP below BY246. There are only 9 big Y testers, so this would, if you say there's one tester for every 5 big Y testers, that'd be 45. That's really an ideal range of 50 to 100. Also, you need to verify that your haplogroup is pretty straightforward, and 75% of the projects or haplogroups fall into that category, being straightforward. And this one turns out to be straightforward because it satisfies all the characteristics. So now you have found a good project. It's BY246. But you really have to check and make sure that it's not well covered in some form or fashion already. So just do the old Google search, put BY246 FTDNA project. First one that comes up is RL21 Baku. And so you click on that link, and in that description, very high up, it says, in terms of a SNP clade, this cluster is BY246, 248. So it's already been covered to a certain degree. Since this project already exists, you should probably join this project and offer your assistance versus creating your own. And also, you should probably encourage a name change so it can be found easier. We had a lot of old projects that they had similar signatures but had no SNPs to match them. Now they're matched. So they need to kind of migrate to the new format of being known by its Y-SNP versus its old name, which lots of projects use in the past. Here's another candidate. Let's say you're BY4027. Well, it looks like it at first glance would be a pretty good choice because you got 3 branches underneath it. And the Z21269 looked like a pretty large one, but you need to go through the exercise to make sure that it is appropriate. So again, we go back to the screen from Big Y, I'm sorry, the BigTree that Alex Williamson produces. And boy, this jumps out. You got a whole bunch of branch equivalents that's much older. So this is not as straightforward as we thought, and we need to look a little more into various aspects to make sure the branch equivalents are not too old or the other characteristics are not correct. So next we look at the age, and we have to do a little translation here. The highest one on Alex's tree is not a branch, but if you do a search under FamilyTree, it comes up as S7834. So you really should go by the FamilyTree name versus the particular first SNP that Alex. So we're going to look at 7834, and lo and behold, it's pretty young. So even though it has a large number of branch equivalents. This is actually in the low end of the range and looks like a pretty good project. So the characteristics look good for S7834. The TMCRA is a little young at 1,560 years, but it's still very, very acceptable. It has a whopping 19 branch equivalents, so that's very good. It has 10 branches on the big tree, but also shows 22 branches on their family tree, which is pretty good. But this is getting to be, even though it's a younger project, it's a much larger project than the previous one. BigTree shows 18 big Y testers, assuming that there's a 20% penetration of big Y testers to 67 marker testers. That's about 90 testers. So that's, still a very reasonable size project. The family tree, public apple tree, if you pull that up and search the geography, it'll actually tell you that there's 40 confirmed testers that are actually confirmed to be. So this all indicates that this is a pretty good haplogroup project to create a project for. So we do a Google search for 7834 and it comes up first as RL513, which has 1,557 members, which is obviously a very big project. If you look at the big tree, that's 3,500 years old, which is way too old for any kind of charting. You're going to have lots of different signatures, probably 10 to 20 major haplogroups underneath that. So it's one of the older and broader branches under L21. So it's probably being covered today in that manner, but with only 4 or 5 project admins and 30 to 50 haplogroups. Creating a haplogroup project is probably a good idea. It covers dozens of haplogroups in the 1,500 to 2,500 year range, and so S7834 may get lost in the mix. The L513 includes 29 testers and another 27 possible testers, so it's pretty well covered already. And so they are recruiting and getting these people to join. And so you need to contact the people and maybe there's somebody that's already doing this already. It doesn't need to be better covered, but you just need to coordinate your activities to see if there's really a need or desire. So you should either volunteer to help the L513 and organize and recruit members and create your own haplogroup, or create your own haplogroup project, but you still should encourage your project to join L513, and you should encourage your people to join L513 as well. So there should be a partnership between the two groups, not a competition. So I gave you a couple of examples of what makes good haplogroup projects, and you go through the same process and see if the one that you're considering is a good project as well. A lot of times it may not be as clean, and it may not be as in the right time frame, or maybe too small or too large. So what is the next step? First of all, you need to go and search Family Tree Day project application form if you decide to create a project, and then go through the procedure of trying to create a project. Now, Family Tree Day will not always allow it. They might deem it too small, and so you need to spend some time on creating this and have a good idea in your description of what you're going to do for this project. And then once you create the project, you got to build the project. You got to recruit. When you create it, there's nobody in it. You can join, and you're the admin. That's one project member. So what you do is get L513 probably to send an email to all their matches to jumpstart you. This is one reason you want to have a good relationship with L513. And also, then you can start using the YDNA match list report and recruiting your own people directly, because having direct access to the email of the tester is much better than contacting surname projects, which is not a very productive way of doing it. So then you may have to create and maintain groupings in your STR reports as well. So there's not just one branch, there's several branches, so you need to kind of create groupings for each branch that you think that each person belongs to, and develop YSTR signatures and figure out the signature of your whole haplogroup so you can determine how the subgrouping should be made. Optionally, you should also track your project members for those failing to qualify in a Microsoft Excel spreadsheet, and you need some place to put the people who you find in other projects, but you have not been able to recruit as of today. Best thing you can do is grow your project because the more information you have, the better. So how do you recruit? What you do, you first of all, you pull up a report called the Member Information Report. You click on the ID of that member, and then you look at the button, hit the button Matches under YDNA, and then under the name column, there are donor names. And when you find somebody that does not look like he belongs to your group, you can click on his name and it'll pop up his email address. And then you can send them an email with a brief summary of why they should join and the steps of how to join. Because it's real important to not just say join our project. You need to explain the benefits of it and also show them step by step how to join. For those who've never been a admin before, you have a responsibility to try to group your people and your projects under the YSTR report. And it's a pretty straightforward procedure. Under the project handbook admin pull-down menu, you select member subgrouping. And then there's a create subgroup. And that's where you enter the grouping name, a short description, and then you have a unique color code that will help separate visually each group. Then to add project members, you just click on the little arrow to the right under Manage column, and then click on Add, and that will move somebody who doesn't belong to a group into a group. Later on, if you decide you want to change some characteristic of the group or split into two different groups, you can go into the Manage group and update this description to a more appropriate description. So once you take your project to the next level, the next level is really you need to take a Microsoft Excel spreadsheet and keep track of all your testers. Spreadsheets are just by far the best method to analyze and track information. Just putting it on paper or using your grouping, you will spend a lot of countless hours with very low productivity trying to do it manually. You can manually predict who belongs to your haplogroup project and who does not belong. That's one of the key things. You don't want people who do not belong in your group. So you need to be able to have a spreadsheet to analyze properly. It also allows you to sort by mutations and see who really belongs to which haplogroup based on signatures. So spreadsheets are your friend, but not everybody wants to do a spreadsheet, and it's not necessary 100%, but it really increases your productivity and allows you to do it. So if this looks like the right thing for you, go ahead and create your project and get it going. People will be thankful. It's a real rewarding job to be an admin. There is a second presentation that shows you how to create a project spreadsheet. It takes you through one column at a time and why they're useful. And you do not have to implement all the columns, and you may want to add a few of your own, but it gives you the idea of the kinds of things that you should have and do with your spreadsheet. Also, for those who really want to take it to the highest level, which is a very small percentage because these are pretty heavy-duty topics, there's an actual full-blown Y-SNP prediction and how to implement it for your particular haplogroup project, as most of these projects that pass the criteria can have 100% accuracy on Y-SNP prediction. And then there's a fourth presentation of once you've collected all your data and have a SNP prediction to make sure all the data is correct and matches, you can actually use a product like SAP to chart and create really pretty charts to show how all your people are working together. Hope you enjoyed this presentation. Look forward to your feedback and comments.